Solving trigonometric equations with various domains. So to start this, we have to do a little vocab first. Let's talk about coterminal angles and what they are. And that is angles with the same reference angle. Now, if you forgot what reference angle is, that's just acute angle that the x-axis makes with the side of the angle you're finding. So, for example, if I said 100 degrees, so we start here, here's 180, 100 will be, here's 90, 100 degrees will be in here somewhere, maybe closer to that, but whatever. Right, 80 degrees would be your reference angle, because the distance from the angle to the x-axis, always to the x-axis. If I wanted a coterminal angle, all you have to do is either add 360 or subtract 360. If I add 360, I get 410, 460, if I do my math correctly. So all that means, if you start here, you go around in full circle, it's 360. And then if you add another 100 degrees, you'll get 460, which will be in the exact same spot. And those are coterminal angles. Two angles are in the same spot and the same reference angle. Easiest way to find them, if you want to find a coterminal angle, just add or subtract 360. In radians, it's the exact same idea, but instead of adding or subtracting 360, you add or subtract 2 pi. So if I gave you an angle, let's say pi over 4, 45 degrees, you want to find something coterminal to that, we'll just add 360, but it's going around a full circle. To do that in radians, all you do is add 2 pi. So you need or subtract 2 pi. So you need a common denominator, 2 pi over 1, 4 times 4. So you get 8 pi on top, and that'll give you 9 pi over 4. And that should be coterminal to pi over 4. We could test it out right now. Right, this is 0. This is pi, or 4 over 4. If you go around again, you'd get 2 pi, or 8 pi over 4. And one more would be 9 pi over 4. So they are coterminal. So if you ever want to find a coterminal angle, an angle with the same measurement, the exact same spot, just forward or back a couple rotations, you just add or subtract 2 pi or add or subtract 360. So why do we talk about that? Because we're going to start solving things with greater domains than just 2 pi. And to do that, we have to know how to find a coterminal angle. So the general rule is here. We're going to solve like normal. And then when you get your answer, you're going to add plus 2 pi k. Since trig functions are periodic, they keep on going around and around in circles. And the way you find it is just keep on adding coterminal angles. So we use 2 pi k, where k could be any integer. -3, -2, -1, 0, 1, dot, 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 right? So any integer, any number that's not a decimal. It could be any one of those. That's what k is. So that's going to be the general idea. We're going to solve this like normal. We're going to add 2 pi k, and then we'll talk a little bit more about it in general. So let's solve this for general. So divide by rad 2. So I get sine of the x equals 1 over rad 2. SOHCAHTOA over h. I have a positive sign. So I'm going to be all students take calculus, which should be an A and an S. And then opposite rad positive. So 1 and rad 2. If you've seen me before, we should know that anytime you see rad 2, it's a dead giveaway to 45 degrees. So we're going to do this in radians. So 45 is pi over 4. This will be 0 and this will be pi. So 4 over 4 is always my trick. Whatever the denominator we're talking about is, just make that the denominator. Make that 4 over 4 here. And then 1 less will get me 3 pi over 4. So those are my answers. And we're going to do it the generic way. So my answer here is pi over 4 plus 2 pi k. That gives me every single answer possible for this periodic function. And we have x equals 3 pi over 4 plus 2 pi k. And now all I gotta do is find the values that fit in this domain, in this thing here. Now the easiest way for me to do it, since we're going to be adding 2 pi, let's figure out what 4 pi is in terms of pi over 4. It's like I did over here, right? This is 4 over 4. If I went around again, it would be 8 pi over 4. How much is 4 pi? Like, what's my max? So, common denominator. And I get 16 pi over 4. So, once I get to 16 pi over 4, I'm going to stop. So that's here. my first answer is pi over 4, right? That's just my generic answer. Or if I plugged in 0 here, I don't need any negatives because we're starting at 0. If I plugged in 1, if I subbed in 1, just counting up, we did 1 rotation, so I did 4 pi over 4, sorry, plus 2 pi, common denominator, 4 over 4. I get 8 pi plus that would give me 9 pi over 4. That's less than 16 pi, so I'm good. If I went again, so I'm at 9 pi over 4, I want to add another 2 pi. I already know what the common denominator is, since this is going to be like 4 over 4, blah, blah. This is 8 pi. I would get 17 pi over 4, which is actually too much. Right, 16 is my max, so 17 is a little too far. So I should only get 2 answers from this one. So it went pi over 4, and then it went around one more time, and it got me 9 pi over 4. I can do the same thing here. I got 3 pi over 4. Now, we should kind of know that. Oh wait, all I have to do is add 8 pi to it. 8 pi over 4 to it, I should say. So my next rotation will be 3 pi over 4 plus 8 pi over 4, which is 2 pi, and I get 11 pi over 4. If I add another 8 pi over 4, I'll get 19, which is going to be too much. So that's my other answer. So those are my 4 answers within the domain they give me. So that's how we're going to do it. So anytime the domain is a little weird, you want to find the generic answers to these things, which you solve it like normal. You add 2 pi k, and then you just keep on plugging in integers until you get all the values that fill up the domain. Let's do another one real fast to make sure we understand it before we get to little crazier problems. This one's already set up for me. Now, tan's a little funky with 1. Normally when you do 1 or negative 1 or 0, it's a unit circle, but not for tan. Tan could do 1. TOA. Opposite of adjacent. All students take calculus. We have a negative tan, so it's going to not be at A and T, it's going to be at the other two, S and C. Tan is 1 over 1, so 1, 1. We have another 45-degree triangle. It's only one that's isosceles. So we're going to have pi over 4 again. So I'm going to use the same trick. Here's 0. Here's pi, or 4 over 4. 1 less would be 3 pi over 4. This is 4 over 4. I gotta go all the way back over to here. So that's 2 pi, also known as 8 pi over 4. It's common denominator. 1 less would be 7 pi over 4. So my generic answers right now are just x equals 3 pi over 4 plus 2 pi k, and x equals 7 pi over 4 plus 2 pi k. Now in this case, they want us to go from negative 2 pi to 2 pi. Now I'll tell you right now, from 0 to 2 pi, those are my answers. Right? This is 2 pi, that's my max. So I'm not going to go any further than these two for 2 pi. But I do get the negative version of that. So for k, if I plug in 0, I get the basic one. If I want to go backwards to get the negatives, I'm plugging negative 1. So this is already one of my answers. And then let's go backwards a little bit. Let's plug in negative 1. So I'm going to get 3 pi over 4 minus 2 pi. Common denominator, 4 over 4. By now we should kind of know it's already 8 pi. So all we're going to do is subtract 8 pi. And I get negative 5 pi over 4. If I went around again, subtract another 8 pi, I would get 13, which would be too much because 2 pi is only 8 pi. So my answers are this guy and this guy. And then for the other generic version, that's already one of my answers. Now let's subtract off 2 pi, or plug negative 1 in. Common denominator, we've done this so many times, you should know it's 8 pi by now. 7 pi minus 8 pi is just negative pi over 4. So that's my other answer. If I try to go back, subtract another 8 pi to get negative 9 pi over 4, which is too big because again 2 pi is just 8 pi. So that's my other answer. So those are my 4 answers. My normal ones and then my negative ones to get all of the negative 2 pi. So let's get a little bit fancier here. I want to solve from x between 0 and 3 pi for this thing. So now notice how there's something in there. Remember the general way we do, so we ignore it to the end. Or some people call that the u sub. Just sub something in place of it. So you just solve like normal. When does cosine equal 1/2? All students take calculus. It's a positive cosine, so it's in quadrant 1 and quadrant 4, A and C. Cosine's the most annoying because the side is 1. That doesn't really help me about the adjacent side. You just gotta know it's a 1, 2, rad 3 triangle. So that's 60 degrees. Or also known as pi over 3. So 0, pi, 3 over 3 is a trick. If you go around again, that's 0 over 3, you get 6 over 3 or 2 pi. And one less would be 5 pi over 3. So we found u equals pi over 3 and 5 pi over 3. And actually, I messed up. Just like before, I should do this. The generic version, what we found was u equals pi over 3 plus 2 pi k, and u equals 5 pi over 3 plus 2 pi k. So if we remember from before, the problem here is that we didn't find you. We were we weren't looking for you. We were looking for 2x. So this is really just 2x. This is a placeholder until we found out what we really wanted. And then what I do next is I try to solve for x. So let's multiply both sides by 1/2. In this case, to multiply everything by 1/2. So my answer here is actually x equals 1/2 times pi over 3 is pi over 6. And 1/2 times 2 pi is just going to be pi. Right, the 2 and the 1/2 cancel out, and I just get this. That's my generic form for this one. Same thing here. Multiply by 1/2, multiply by 1/2, distribute. I get 5 pi over 6 plus pi k. So in this case, this is my generic answer. So my generic answer is pi over 6 plus pi k, and 5 pi over 6 plus pi k. But I want all the answers between 0 and 3 pi and 3 pi. So I'm going to do this like before. What's my max? Well, we're talking about in terms of 6 here. So over 1, common denominator, 6 over 6. 18 pi over 6 is my max. My min is 0, but I pretty much already hit it. Pi over 6 is going to be one of my answers. And 5 pi over 6 are already the closest to 0 we have. So let's go a little further. If I add 1 period to this guy, if I plug a 1 for my k, that's a k, I swear. I get pi over 6 plus pi. Common denominator is 6 over 6. So I get 7 pi over 6. That's less than 18 pi over 6, so that's another answer. And we can keep on going. Add another period. Now if you add another pi, we should already know it's going to be 6 over 6 again. So I'm going to get 13 pi over 6. That's still less than 18 pi, so that's another answer. If I try to go one more time, I'm going to add another 6 over 6, I'm going to get 19 pi over 6, which is actually a little too far. So those are 3 answers I get from this the top side. I get pi over 6 plus another period, which will get me 6 over 6 plus another period, which will give me 13 pi over 6. Now remember, it's only a period here because we started with 2x, and then when we multiply both sides by 1/2, it canceled out. So it's actually shorter periods. I still got to do this side. I mean, I already did the basic one, 5 pi over 6. But let's do all the other rotations. So let's like plug a 1 in. 5 pi over 6 plus pi. We should know by now it's 6 over 6. All we're really doing is adding 6 to the numerator. So I get 11 pi over 6, which is less than 18 pi, so that's a good answer. If I add another 6 to it, right? So if I do another rotation plus another pi, I would get 17 pi over 6, which just fits into that thing. So it's another answer. So you actually have 6 answers here. So sometimes when we have the domain, it gets a little messy. By the way, even if this was 2 pi, you still have to, you're still have to find the generic form, because anytime they mess with your, like, it's not just a normal x here, it's a composition of functions. You got to try all the forms, because you'll get more answers than you're used to. So it's something to look out for. For the sake of time, we'll skip this one, and we'll go on to the third one here, the last one of this type. But if you notice, it is cosine equals 1/2, which we already solved right here. Cosine equals 1/2. So I know I'm going to start off with just our answers. Our basic answers are pi over 3 and 5 pi over 3. So we're going to skip that ahead. So if I do cosine, if I do a little u sub cosine of u equals 1/2, I already know that this is u equals pi over 3. And we can't forget about the generic form of this. So plus 2 pi k. And then u equals 5 pi over 3 plus the generic form 2 pi k. So, and just like before, since anytime there's something inside, you actually didn't solve for that, you solved for u, not this thing. So let's plug that in. So it's actually x minus 2 pi over 3 equals pi over 3 plus 2 pi k. And same thing here, x minus 2 pi over 3 equals 5 pi over 3 plus 2 pi k. And then to solve it a little bit, add 2 pi over 3 on both sides. In this case, I get x equals pi, so I just get 3 over 3, which is also known as pi, plus 2 pi k. And on this side, I would get 7 pi over 3 plus 2 pi k. Now, so those are my generic answers, but again, they want all the answers in this domain. Now, in this case, I'm going from negative 2 pi to 2 pi, so this actually should be pretty fairly easy. This is a fraction, so I want to figure out what my max and min are here. 2 pi is generally one of the easier ones, over 1. My max is going to be, common denominator, 3 over 3. So 6 pi over 3 is the max I could get to, and the min would be the same thing, just negative. So do we always do, right? So my answer here, you always start off with k, right? They're integers, so if you start with 0, plug in 0, you get pi. That's in the window. What if I plug in 1? Pi plus 2 pi, that'll give me 3 pi. Too much, not an answer. What if I put negative 1? I'll get pi minus 2 pi, which is actually gets me negative 1. Negative pi. That's in the domain. So negative pi is also an answer. If I try going back one more, I'll subtract another 2 pi, which will give me negative 3 pi, which would be too far. So I get 2 answers from here, which is kind of the industry standard. Over here, same idea. If I plug in 0, I just get 7 pi over 3, so that's an answer. It is not an answer. What am I thinking? The max is 6 pi over 3. That's not a good answer. So I'm not going to go any higher because it's already too much. But I might have to go lower. That's a good one to see though, right? The generic answer I got does not fit in my domain. So I got to watch it. So let's go back instead. Let's plug in a negative 1. So 7 pi over 3 plus 2 pi times negative 1. Again, we should count the denominator now. It's going to be negative 6 pi over 3. Like that's what 2 pi is in terms of 3. So I'm just going to get pi over 3. And that fits the domain. If I subtracted another negative 6 pi over 3 to do another rotation, I'll actually get negative 5 pi over 3. And that fits the domain. So those will be my 4 answers. Right, so it always kind of starts the same way. You solve it like normal, do the generic form. After you do the generic form, you're just going to plug in integers that fit into the domain. And keep on trying until they fit into the domain. I like to figure out the min and max part to see it's a little easier for me to see what fits in the domain. And also don't forget, if your problem's a little worse than normal, right, there's a composition of functions there. After you ignore it, you bring it back, that might affect your thing here. In this case, it didn't because we were adding. But in the first case, it did because we were multiplying and dividing. So when I multiply by 1/2, it affected both of them. When you're adding and subtracting, it only affects the one that it could add to, so it wasn't as big of an effect. Okay, one last problem. We're just going to skip this one, go down to here. Let's talk about how to solve stuff using our calculator. So we're going to solve equations now with the vast domain using our calculator. So look at this problem. The population of water buffalo is given by this equation there, where t is the number of years since the first settlement. So p is population, t is years. What was the initial estimate? Well, initial value is always t equals 0. Now we can solve this by hand, but we could use a calculator for application problems. So all we have to do is sub in 0. So let's bring in our calculator. Now we're going to do this a couple ways. First, I'm just going to type it in into our normal home screen. Now if I do this, we want to make sure you're in radians, because by default we use radians unless they specifically say. So I'm going to turn it on, go to mode. It is in radians. And I'm just going to type in 400 plus 250 sine of pi over t. So we don't have a t button, so we always use x divided by 2. And actually in this case, I'm plugging in 0 for x, so that has to be a 0 actually. So let's go back in there, hit a 0, hit enter, and I get 400. So again, we could have done that with our hand, but we could have done that by hand also. But when the numbers get a little funkier, you're going to want to use a calculator. Like the next one, find the first time when the herd exceeds 500. So I want to know when the population is greater than 500. So let's write that down. So I want to figure out when 400 plus 250 sine of pi t over 2 is greater than 500. And the best way to do this is to graph with our calculator. So I'm going to go y equals. We're going to type this in from our y1, or should I say this side from our y1 and this side from our y2. So 400, I'll type that thing again, plus 250 sine Now this is where the fact that we don't have a t comes in. So it'll be pi x. We always just use x for our variable. Divided by t, 2, I should say. So that's my top equation. And then my bottom equation here is 500. Now I'll figure out where they first cross. Now if I hit graph, you're gonna notice you're not gonna be able to see anything. Look at this function right here. It's going all the way up to 400. In my current windows, it's standard, so it goes like negative 10 to 10, 10, 10. So it's not anywhere close to this. So we gotta fix our window. So X-min, X-max, they actually don't really give you guidance. So probably one period would be good. So let's try to figure out what the period is. Right, 2 pi over b. My b is pi over 2. So 2 pi over pi over 2. Which would be 2 pi times the reciprocal. So 4. So maybe I just want to go to 4 as my max. I'll start at 0 and go to 4. Why am I starting at 0? Because we're talking about time in years, so negative years generally doesn't make sense. So 0 to 4 is pretty good. Because that'll give me one rotation, one period. How about my x-min, max, x-max? Well, we talked about that, right? The way you find the min of a sine function or of a cosine function, of a trig function, is you get the vertical shift and add the amp. So 400 plus 650 plus 250. Sorry, I did the math in my head. Give me 650. That's actually my max, not my min. And my min would be the opposite. You get the vertical shift, 400, and you subtract the amp. Right, because the vertical shift is like your new middle. Then you just go up and down the amp. So that'd be about 150. So if I type that in for my min, I type 650 in for my max, I should get a graph I could see pretty easily now. Right, and then there's the 500. So I want to find the first time the herd exceeds 500. So I just want to figure out where they intersect. So I gotta find the intersection. You hit second calc, find the intersection. It wants the first time. Now remember, you can move it like this. I think that takes too long when it's a curvy one, so I usually press up or down to go to the straight one. It's a little bit faster. Just want to get close to it, hit enter a couple times. First curve, it jumps to the second curve, and then enter. And the intersection is 0.2619. So our x equals 0.262. So around there will be the first time it exceeds 500. That's the idea.